question number 2 on page 3. It comes from chapter 2 on rational numbers, and it's basically an order of operations question involving fractions. So we have 2 operations. We have a subtraction here, and we have a multiplication, and we know that according to order of operations, we do multiplication first. So we have to multiply 3 1/4 by 1 1/5 first. Now, what I always suggest to my students is that you first convert any mixed fraction to improper. I'm a big fan of just working from it from improper form. It's easier. So if we look at 1 1/5, how many fifths does this one have? Well, there's 5 fifths there, plus one more fifth. That's 6 fifths altogether, and so on and so forth. So changing a mixed fraction improper or a mixed proper to mixed should be something everybody's fairly comfortable with. So we have multiplication of fractions first. And the most common mistake I see people make is trying to find a common denominator. But when you multiply fractions, you don't need to find a common denominator. You simply have to multiply the numerators and multiply the denominators. And what you could do is multiply those numerators, multiply the denominators, get an answer, and then reduce that answer to lowest terms if you want. Or, if you would like, you could then reduce it before you do it by using what we call cross reduction. So if we look at 13 over 4 here, I can't reduce that fraction. I can't reduce 6 over 5. However, if I was to think about those numerators being switched, and I've thought of the 6 as being over the 4 and the 13 being over the 5, if I was to switch those numerators, you can kind of see it like that, I would still get the same product, because if I was getting the answer, I'd go 13 times 6 is, what is that? That's 60 plus 18, 78. But if I did 6 times 13 over here, I'm still going to get that same numerator, even though I switched them. So what we can do then is, because we did that, is we can cross reduce. So 6 over 4 is really 3 over 2. And we can, it's a long, I should give you another film on it later on because it takes a little while to explain, but we can cross reduce that and we can get 39 over 10. So we have negative 3 over 2, take away 39 tenths. And we'll just put it as 39 tenths here. We have one operation left. We're going to find, now that we're subtracting, we're going to find a common denominator. So we are going to use 10 on that one. What's an equivalent fraction to negative 3 halves that has a denominator of 10? That's going to be negative 15 tenths. Take away 39 tenths. And what I recommend people do is that when you do that, make sure you rewrite it. I like to rewrite it just like this, because the rule is when you subtract fractions, you got to keep the denominator the same and subtract the numerators. So as we see here, that's when you subtract those numerators, this is what it really looks like over here. And when I'm subtracting, I want to change to addition and use the opposite of the second integer. So I really have negative 54 tenths, which is negative 5 and 4 tenths, or negative 5 and 2 fifths. That's your answer for that question.